In this lesson, we're going to take a look at solving right triangles. So let's take a look here. Here we got a blueprint for a house. The house we've kind of been looking at in the other lessons before this. And we've got a lot of right angles. But if you look close, you'll notice that architects usually don't put angles in a drawing. Now, sometimes in blueprints for something that's being machined, we'll have angles in there, but often there's a lot of angles that aren't labeled, but there's a lot of lengths. And so we need to figure out how to get these angles for the lengths. Now, there is something here, and that would be this slope right here. Okay, this is called the roof pitch or the slope, all right? And here this says that we have a roof pitch in this particular house that is 5/12, they call it, all right? They say it's 5/12, which means 5/12. And so that's the rise and the run, the slope or the pitch of the roof. Now, if you're building this house and cutting these boards and all that, you need to know what these angles are. Because this right here, angle, whatever, this beam, this board right here, has an angle right there. And that angle, and this angle here, that all has to do with this 5/12 going on right here, all right? So, the question is this. If we look at those blueprints above, we'll notice there's no angle measurements, as we just said, a bunch of 90 degrees. We do have the pitch, that's 5/12. So in this 5/12, what is the angle of this roof? Okay, so we've got 5 and 12, all right? And let's see. We may recognize this triangle from previous lessons, but let's try this out. Now, we know that there's some angle. Let's call this angle here angle A, all right? Here's our angle A. So, too big fat A. There we go. And so we got this angle A, and we've got this side. What is this side over here? Oh, this leg over here. That's the opposite, right? And what's this leg? That's the adjacent, right? And so we're looking for some angle. I don't know how big it is. Some angle A that has a tangent of 5/12. Now remember, SOHCAHTOA, right? So this is just a way to remember if we have the opposite and the adjacent, well, that's going to give us tangent. All right. SOHCAHTOA helps us to remember which one's which. Great. Now, so let's see if we can find a tangent of 5/12. First of all, let's go to our calculator here, and we'll figure out what is. Let's get 5/12 as a decimal. So we have 5. So 5/12 is about 0.416, repeating there, all right? So we're looking for some angle that has a tangent of 0.416. I don't know what it is. Let's try. So the tangent of, let's try 40 degrees. Whoops, got to get that inside. So a tangent of 40 degrees. Okay, that's 0.48. I'm sorry, 0.83, can't read. 0.4, all right, so nope, that's too big. So let's change that, maybe a tangent of 30 degrees. That's 0.57. Maybe a tangent of 20 degrees. Oh, I'm getting closer. That's 0.36. Maybe 25. Ooh, we're getting real close, too high. So 24. 22. Ooh, 22 is too low. 23. 23 is too high. 22.5. Oh, we're getting pretty close here. Okay. 22.6. The tangent of 22.6 is really close. We're getting close to 5/12. So the tangent of 22.6 is really close to 5/12. All right. So it looks like that angle, which, if you remember from lessons before, we've seen that. Oh, so we can kind of guess and check there, and it comes out to be 22.6. And hopefully, in your head, you're saying there's got to be a better way. Guess and check is, that kind of took a little while, and so we're going to come up with a better way to find that. All right, right now. Right now, that's all we have is that guess and check. So, great. All right. So let's see what we can figure out. So when we have a mathematical function, whether it's addition, subtraction, or something like that, we always have an inverse, or we almost always have an inverse function. So an inverse function is something that does the opposite, all right? Inverse does an opposite of the original function, okay? Or you can kind of think of it like an inverse kind of undoes the original function there, all right? So like the inverse of addition, 5 plus 3. The inverse would be, if we have our inverse, would be to subtract 3, right? If you take 5 and you add 3 to it, then if we subtract 3 from whatever we get, that would be the inverse, all right? If we take the inverse of multiplication, so if we have 5 times 3, well, the inverse of multiplication is division, all right? So they're kind of opposite, these opposite operations. If we have 5 squared, if we take 5 and square it, we get 25. Okay, so the inverse would be dividing, all right? So what this means is if we start, let's say, again, if we start, we do 5 plus 3, we get 8. And then we subtract 3, that takes us back to 5. 5 times 3 takes us to 15. If we divide by 3, that takes us back to 5. 5 squared takes us to 25. And if we square root 25, then that gives us 5. Okay, so these are inverse operations of these things that are going on over here. All right, so inverse is something that is the opposite or undoes. So now we have trig ratios, sine, cosine, and tangent, and we need to go backwards. Okay, so remember when we had in our last lessons, we were finding sine, cosine, and tangent, and we used that to find missing sides, right? Okay, we said if we have 30 degrees here, then we can find the sine of 30 degrees. Okay, and that turns out to be a half actually, all right? So if you know the angle, you can find the ratio of these two sides, the opposite and the hypotenuse. Okay, so here we started with an angle, and we used sine to find the ratio of the sides. Okay, well now we don't know the angle. We're trying to find the angle, so we need to go backwards. Instead of starting from the angle, we're going to go back to the angle. So this going backwards is called finding an inverse. So these are our inverse trig ratios. So if we have a right triangle, and some angle A is one of the acute angles, then we've got these ratios. So we got the inverse sine ratio. Inverse sine ratio just says that if the sine of angle A is R, so we've got the angle measure and we got some ratio. Then we can go backwards. If we do sine -1, it looks like a -1 power. It's not really an exponent. We read this as the inverse sine of R is the angle. So the inverse sine of the ratio is the angle. Or another way that that's written, we sometimes see that as arc sine. We won't see it a lot like this. We'll use this one mostly. But you'll see it as arc sine is another way that it's been traditionally written. So again, the inverse here is going to find the angle. The same thing's for cosine. If we know that we've got the cosine of an angle is R, then the inverse cosine will give us the angle or the arc sine. And same thing for tangent. So the key here is that the inverse finds the angle, all right? So we read this sine -1 as the inverse sine of R, or sometimes we call it the arc sine, all right? So the inverse sine is how we read that. Okay, great. So the key is that when we're finding the inverse sine, that means find the measure of the angle. Okay, it has that has a sine of ratio r. Okay, so when we're finding the sine -1, we don't read it as sine of the -1. We read it as inverse sine. That's finding the measure. It's asking a question saying, what is the angle that has that given sine? All right. So let's use that a little bit here. Let's try that out. Here we have a triangle. Okay. And in this triangle, we want to use this triangle to figure out which angle here has a sine of 0.6. 0.6. Do you recognize that? 0.6. 0.6. Well, we have a 6, we have an 8, we have a 10. Oh, well, 0.6 is 6/10. Right. So this is the same thing as saying the inverse sine of 6/10. So this is saying the question is what angle A or angle B here, what angle has a sine of 6/10? Well, sine, let's think back. Let's go to our little SOHCAHTOA way of remembering here. Sine is opposite over hypotenuse. So 6 and 10 is what we're using. Oh, this is opposite of B. And the 10 is obviously high. Okay, so the inverse sine of angle 6 is angle B. Okay, the inverse sine of 0.6, sorry, is angle B. All right, and that's the measure of angle B. So, okay, which angle has a tangent now of 4/3? 4/3, there's no 4/3 here. Oh, well, there is an 8 and a 6. And so 4/3, well, that comes from 8/6 is the same as 4/3. So let's kind of get rid of that there. Okay, so, oh, that's the same as saying the inverse tangent of 8/6, or we're saying which angle has a tangent of 8/6. Well, tangent is opposite over adjacent. So, 8 is opposite of A, or to angle A, and 6 is the adjacent to angle A. Okay, so that's opposite adjacent. Oh, that's angle A. Okay, or the measure of angle A, and this would tell us the measure of angle B. Now, so what are those measures? So here we just kind of identified which angle in this triangle we're talking about. Now, if we actually wanted to find it, we got a couple ways. One way that this has been done traditionally in years past is with a trigonometry table. All right, so here's a table, and it's kind of broken up because for room's sake, and so there's these tables you can look up. You can look them up online. They're in books and stuff. So these are some angles: 0 degrees, 1 degree, 2 degrees, so on and so forth. And these are the sine, cosine, and tangent of those angles. So if you have an 8-degree angle, it has a sine of about 0.1392. That's rounded, and cosine about 0.9903, and 0.1405 is a tangent. All right, so we can use this kind of backwards. Remember, we're looking for the angle. So here we want to know what angle has a sine of 0.6. Okay, so we're looking for sine of 0.6. Nope. Ooh, there's one. It's about 37. Actually, a little bit less. Okay, so we can say that it's about 37 degrees there. That's close. Okay. Because that sine is 0.6. All right, so let's call that approximately 37 degrees. Okay. Now, for some situations, rounded to the nearest whole number is okay, but if you were trying to do something like making something that's precise out of metal, or something that fits real nicely, that 37 degrees is not quite close enough, okay, because we had to round there. But we'll leave it at that for now. Let's see. 4/3. Well, 4/3 is 1.3 repeating. So I wonder what angle has a tangent of 4/3. Okay, let's see. Tangent of 4/3. We're looking down the tangent. We're looking for 1.33. Not there, not there, not there. 1.32. Oh, this one kind of got cut off. That one is going to be a little bit higher, so I think we're going to go with 53 degrees about, all right? So that one's about 53 degrees. I think the next jump is a little higher, so 53 degrees. Okay, uh, great. Well, and we have ways, and back when I was in school, back before the calculators, back in the Stone Age, we had to kind of approximate that before the calculators would do it for us. So, but we do have a tool now. So let's see how we can use our calculators to find this a little more exact. These days we have our scientific calculators to help us out. So our calculators basically have these memorized. We don't need a table. And our calculators can find them for us, and it actually can find them a lot more accurately, not just to the nearest whole number, but it can get a lot more accurate. So if we want to find that sine of 0.6, or that inverse sine, sorry, not sine, remember it's inverse sine, because at -1, we're just going to go to our scientific calculator here. So we'll come on over here to Desmos, and we've got the inverse sine. So on most regular scientific calculators, you'll see sine, cosine, and tangent right on the front of it. Sometimes you got to hit a second function or a shift function. On Desmos, we just go over to these functions. There it is, inverse sine. We do have to make sure we're in degrees. Can't be in radians. If it's in radians, then this is totally different, okay? Radian is a different way to measure angles. So we want the sine, we set a point, the inverse sine of 0.6 there, okay? And it comes out to be 37.869896765. We said it was 37 when we look at the table, but it's closer to 36 point, let's go 87, all right? So this is about 36, sorry, what did I say? 36.87, short-term memory here, okay? Now that's a lot more accurate, all right? So we can do some rocket science with this stuff now. And if we want an inverse tangent of 4/3, now here we did a decimal value, so this time now, let's go ahead and do an inverse tangent, and we can do a fraction. So we can type it in as a decimal or a fraction. Either one is fine. There it is, 53.13. I think we said 53 degrees, but it's more like 53.13. So we were close, but we can get a lot more accurate answer here with our calculator. All right? So remember, we're looking for the angle that has that sine or tangent, all right? Now, here's a little different question, similar question, but written a different way. Find the missing measures using a calculator. So here we have a basic equation. The cosine of b equals 0.2357. Well, what is it that we don't know? We don't know b. B is the angle. So first thing we should get in the habit of doing is rewriting this as an inverse cosine. Really, we could also say we're going to take the inverse cosine of both sides because it counteracts it, or it undoes the cosine. But we want to rewrite. So b is the inverse cosine of 0.2357, and we can go to our calculator here, and we can punch that in, 0.2357, and we get 76.36711, so on and so forth. How about 76.37? All right, again, we weren't told what to round to. 76.37 works great. So b is approximately 76.37 degrees. We'd still have to say approximate because we rounded there, all right? Well, if we know the tangent of r is 5/12, that's what we know. Well, 5/12 is the ratio. We're looking for the angle. We don't know the angle. So we've got to rewrite it. The angle, we're looking for r, the angle that has a tangent of 5/12. In other words, we need the inverse tangent. Remember, inverse tangent means what angle has a tangent of 5/12. That's what we're looking for. What angle has a tangent of 5/12? So let's go to our handy dandy calculator. And we're going for the inverse tangent of 5/12. We want to know what angle has a tangent of 5/12, and that is 22.6. Okay, hey, that's what we were looking for at the very beginning. Remember the roof there? And we have 22.6198, so on and so forth. So about 22.62 degrees. All right. So that was the original question we wanted. We kind of guessed and checked back at the beginning. And we kind of got close to 22.6. If we wanted to be super accurate, we could use all of these decimals for our angle. All right, and that was our roof pitch, if you remember back at the beginning. All right, so that 5/12 means anytime we're cutting a board, and you know, if we're cutting a board, we're going to have these angles that are 22.262 or some relation to that. All right, 22.62. This other angle, if we subtracted from 90, this other angle would be what? 67.38 degrees. All right, so sometimes we're going to cut at 22.6, sometimes we're going to cut at 67.38. All right, okay, great. Now let's do our last thing here. Is we want to put this all together and do what we call solving right triangles. To solve a right triangle means find all the missing angles and missing sides of the right triangle. All right, so here we have some right triangles. We've got a couple things given to us, and we want to find the rest of it. Okay, so here we have a triangle. We've got two sides, 3 and 6.6. Well, let me call this little side down here D. Do we know how to find a missing side in our right triangle? If we know 2, I think we do, right? We've got good old Pythagorean theorem. Can you write your Pythagorean theorem out? Try it out if you're following along here. Should get something like this. Make sure to put that 6.6 in the hypotenuse spot, all right? All by itself over there, okay? And so we get 9. This guy comes out to be 43.56. Okay, you can actually leave it alone and go to your calculator. I'll show you in a second there. You can get this a little quicker. You don't even necessarily have to find all the in-betweens out there. 43 minus 9 is going to be 34.56. And we're going to square root 34.56. All right, so let's try that. And we get 5.87. Now, we could have just left it as with the squares and let the calculator do the work, by the way. It was 3 squared, which we know what it is. But if you just leave it as the squares and put it all together, you get something. Okay, 5.8787. We'll round that off to 5.88. How about that? Well, let's see. This is to 1 decimal place. This is to the nearest tenth, so 5.9 would be what we got here, all right? So D is approximately 5.9. Now, we need to find all the angles, though, also. So we found D, 5.9, but we didn't find the angles, okay? Well, if we want to find the angles here, we want to use the 3 and the 6.6. We rounded the 5.9 off. That's not exact. We really shouldn't have put an equal sign here. We really should put approximate. There we go, some approximation. Okay, well, let's find angle A. We know this is the opposite to angle A, and this is the hypotenuse. Which one is opposite hypotenuse? That's the sine, SOHCAHTOA. We know the sine of A is 3 over 6.6. So how do we go backwards to find the sine? We rewrite this as the inverse sine of 3 over 6.6. It's fine that it has a decimal in there. That's cool. And so now we can go find out how big angle A is using our calculator. So we'll come on over here, 3 over 6.6, inverse sine of 3 over 6.6. Okay, and we got 27.035. Now the other angle is going to be, they're going to add to 90 there. So we're going to subtract that guy, and we'll get a 62.96 or a 63 degrees. So we got a 27.0 and a 63 degree. So this comes out to be 27.0 when we round. And then since that's 27 degrees, this guy's going to be, subtract that from 90, 63 degrees. All right? And we have solved the triangle. That's the idea. Okay? Well, how about this one? This 4 kind of move. This 4 is this side length here, QR. All right? So let me write that down there a little clearer. 4, all right? We need to find all the angles and all the sides. So it might help to go ahead and throw some variables in there if it's not, all right? Or we can use PQ and PR, okay? Would be good. So this angle here, we know these two angles have to add up to 90, right? Because they're 180 and we already have 90. These have to be complementary. So if we take 90 and minus 36, that's going to give us the measure of angle R. Okay, and that's going to be 54, right? Subtract 30, subtract 6, we get 54 degrees. So measure of angle R is 54 degrees. That's exact, all right? Now, we need to find X. So how does X relate to, well, use either angle, it doesn't matter. Let's use the 54. How does the X relate to the 54? It's opposite. And how does the 4 relate to angle 4 or 54? The 4 is adjacent. So opposite and adjacent, that is tangent. So we know the tangent of this 54 is opposite over adjacent, right? Tangent is opposite over adjacent, we've learned. And so the opposite is X, the adjacent is 4. Okay? Tangent of 54 degrees we know is just a decimal. So let's go ahead and multiply both sides by 4 because we've got to get that X by itself. And that gives us 4 times the tangent of 54 degrees is going to be equal to, and these cancel. So that's X. And so now you go to our calculator, 4 times the tangent of 54. 4 times the tangent of 54. Okay, and that's 5.50555. Okay, so it looks like 5.5, pretty close, pretty exact there. Okay, so this X is 5.5. Okay, now we want to find Y. We could use the Pythagorean theorem here, 4 squared plus 5.5 squared equals Y squared. That'd be cool. I want to try to avoid using the 5.5 because that's rounded. So let's try some trigonometry to finish this off. Why not use a 54 again? So, or yeah, let's use a 54. Or let's use a 36. Why not? 36. Okay, let's use the 4. We want to use the 4. That was given to us. That's exact. And we're trying to solve for Y. And so let's use the 36. The 4 is opposite. And the Y is the hypotenuse. Which one's opposite and hypotenuse? Sine, cosine, or tangent? Opposite and hypotenuse. Opposite and hypotenuse. Ooh, that's right. That's sine. The sine of P is opposite over hypotenuse. Okay, so now we got the sine of angle, which is 36. The opposite of the 36 is 4, and the hypotenuse is Y. All right, and so now this is the one that's a little more challenging because the Y is on the bottom, so it helps to make this into proportion. Now you can cross multiply and divide, right? Okay, and if we cross multiply, we get 4 equals Y times the sine of 36. Sine of 36 is just a decimal. If you want to go punch in your calculator, go for it. But you actually don't have to. You can leave it as sine 36 for the moment. Okay, and sine 36 is just a decimal. Keep that in mind. So we have Y times that decimal. And so let's go ahead and divide by that decimal. Divide by sine 36. Divide by sine 36. And those guys are going to cancel. So Y equals 4 divided by the sine of 36. Okay, and so 4 divided by the sine of 36 gives us about 6.8. All right, So 6.8 it is. Okay, want to remind you here, we could have right up here just swapped this y and the sine 36, and they're going to trade places. You have y over 1 equals 4 over sine 36. That gets us right here. So, that kind of skips one step. But 6.8 is what we got there. Great. So we found all the parts. A lot going on here. But this guy is 6.8. Found that. Found the 5.5. Found the 54 degrees. Okay, we have solved the triangle. That's how you solve a triangle. Great. Well, we're going to leave it at that. And so now remember the key. If you want to find an angle, we use the inverse trig. To find an angle, use inverse sine, inverse cosine, inverse tangent. To find a ratio, use regular sine, cosine, and tangent. All right. Keep at it. With experience, this will make sense. So you're going to do great.